Thanks a lot, Beth and Raul and Henrik, for organizing this. This is probably the biggest audience I have had for a talk related to this package. So just to give you some background, as Bethan explained, I'm actually a researcher in psychology, but I was actually trained in physics. Currently, I do research in public intuitions about artificial intelligence. And I started developing R packages when I started toying around with R and fell in love with it. And I would like to talk to you about this package I have been developing for the last 3 years now, which is an extension of ggplot2. Right. So what's the plan? First, I would like to talk about why this package exists, and I'll just give a brief demo of the primary functions involved in this package, then benefits and customizability of the package, and I'll just clear up some misconceptions and its limitations. So why ggstatsplot? So currently, if you go on CRAN, which is the central archiving platform for R packages, there are over 16,000 packages. So anytime someone introduces a new package, the question is why this package should exist. And the short answer is that this package provides a collection of highly information-rich plots that contain statistical details and is suitable for scholarly publications and also for quick exploratory data analysis. And I'll try to convince you that it's a helpful package when you are exploring, when in the exploration phase of your data. So typically your data analysis workflow will look something like this. You import the data, you tidy it up. This is from the tidyverse philosophy of data analysis. And then you transform the data, visualize it. And this involves 2 steps: data visualization and modeling. And visualization can inform the kind of model that you choose to work with. And the modeling itself can suggest a different approach towards visualization. And this loop goes on and on. In ggstatsplot, the central idea is simple. You just combine these 2 phases into one, where the plots themselves contain the statistical information. I shouldn't even have to say this. The information-rich graphic can be worth 1,000 words unless you actually plot the data. It's highly difficult to trust the statistics that you get. So it's always good to look at the underlying data. Now, the grammar of graphics, which is implemented in ggplot2 by Hadley Wickham, it's a very powerful framework and proposed by Wilkinson. And it lets you prepare graphics tailored to your specific data visualization problems. And literally, you can make infinite number of graphics, each designed to your own problem. But this also requires sometimes a lot of customization. And anytime you have to work towards making a plot of your choosing, this can hinder data exploration phase, because you can develop a habit of not investing enough time. And after time, you may not actually visualize the data just because it requires so much effort to plot the data. So at least in the exploration phase, it's always nice to have a package that can do this for you without any customization. So you basically have the customized plots prepared for you. All you have to do is give it data. Another issue is across packages, there can be a lot of inconsistency as to how the arguments are entered. So for example, this is 3 different ways of computing a correlation between 2 variables and comes from the same package, but depending on the function, the actual syntax can vary differently. And this can create kind of a hurdle that one has to overcome, because every time you have to use a certain function, you have to think how the data should be entered. On the other hand, in ggstatsplot, the API is really consistent. The functions always expect a data frame, and the data is always expected to be in tidy format, not in Cartesian or wide format. And most of the time, the functions, the defaults are suitable enough for your purposes, and the arguments are always data X and Y. So you don't have any cognitive fatigue about figuring out what arguments the function will be expecting. So just to get started, here I'll be talking about the latest version of this package, which is 0.6.8. And there'll be a new version 0.7, which will be out in a couple of days. And there'll be some additional features that I'll be showing in this demo. You can also get the development version of this package from GitHub. And we'll just load the needed packages, which are, of course, ggstatsplot and also ggplot2. So here are the primary functions, and I'm going to break down the primary functions based on the hypothesis we have in question. So when we have hypotheses about group differences, there are 4 functions that can be useful. Ggbetweenstats and ggwithinstats are for multiple group comparisons, and gghistostats and ggdotplotstats are for single group distributions. So this is what the ggbetweenstats function looks like. This is for between group comparisons. On the left side, you see the code required to create the visualization on the right. As you can see, it expects only 3 arguments, data X and Y. And as can be observed from the plot, you get a whole plethora of rich information. So the defaults return raw data and distribution. They also give you descriptive statistics. They give you the statistic and p-value, effect sizes, and their confidence interval, number of observations. If you look at the caption, they also give you Bayesian hypothesis testing, so base factor for the test in question, and also Bayesian estimation. These are posterior estimates. Now, if some of this you don't know what these details refer to, you can ignore them for now. I'll come back to that later. But right now, the only thing that I would like to draw your attention to is when you're exploring a data, and if the 3 arguments can return you such a rich, can paint such a rich picture, you can, this basically makes it easy for you to make sure that everything is working well and there's nothing wrong with your data. So for example, here I can, if I look at the x-axis, I can also see that each level has a number of observations. So this can tell me if something went wrong in random assignment or what have you. Yeah, and if you look in the above the violin plots, you will also see that there are pairwise comparisons which are shown. And that also shows the p-value for this comparison, and it's home corrected. And if you again look at the caption, it will tell you which pairwise comparison test was run and which comparisons are shown. Now, these defaults are customizable. So if we go to the next slide, we see that I have changed the type argument to NP, and I have set pairwise display to NS. Now, the type argument can take 4 different values: P, which will give you parametric, NP, which will give you non-parametric statistics, R, which will give you robust statistics, and BF, which will give you Bayesian statistics. And as you can see, once I change type is equal to NP, the plot changes. So now you have a Kruskal-Wallis test, and you have an appropriate effect size measure, and the centrality measure has also been changed from mean to median. And also the pairwise comparison test has changed from Games-Howell to Dunn test. So the function will take care of everything for you once you change the type argument. And setting pairwise comparisons to NS now shows you only the non-significant comparisons. Before it was showing you only the significant comparisons. This function can also be helpful for outlier tagging. So once again, here I have changed the type argument to R now, and now it has changed the statistics to robust statistics. And now we're running a trimmed means ANOVA. But if you see, there are 2 more arguments here. One is outlier tagging. When set to true, it will label the outliers, and for labeling, it uses the Tukey's fences method. And using the outlier.label argument, you can decide which variable from your data frame will be used to label the outliers. So for example, this is a data set related to movies, and I'm tagging on y-axis, you have IMDb ratings. So if I'm interested in which movies are performing exceptionally well, I can use the outlier tagging method, and it will show you both really good movies and really bad movies. So for example, here you see all the Lord of the Rings movies and some movies which are not that great. And the centrality measures will, of course, depend on which type you choose. So for example, for robust, it's trimmed mean, and that's what's being displayed. Now, the next function is ggwithinstats. This is exact replica of ggbetweenstats, but this deals with repeated measures design. So as you can see, the plot structure pretty much remains the same. The only difference is that there is a line connecting means, just to show that these are repeated measures data. And again, you can change the type argument, and the statistics will adjust to that. And once again, appropriate effect size measures, the statistics, and the Bayesian testing is being done by the function. So the next function is gghistostats. Now here the hypothesis is about a distribution of a numeric variable. So for example, here the question I'm interested in is whether the budget, the average budget for a movie is different than $30 million, right? And as you can see, this is not supported by the hypothesis testing, by the p-value displayed here. Once again, you're getting by default counts and proportions for bins. You have descriptive statistics. You get statistics plus p-value, effect size, and its confidence intervals, Bayesian hypothesis testing, and Bayesian estimation, and it's shown in the caption. So you always have in a plot two components. In subtitle, it'll be frequentist statistics, and in the caption, it'll be the Bayesian statistics. And this is the default for every function. If you change the type, the plot will, or the details will change in the subtitle. Now, sometimes the distribution of a numeric variable has to do with the labeled numeric variable data. And so, for example, here we have labeled numeric variable, which is the genre of the movie. And now we want to see if the budget is different than a hypothesized value of $30 million across different genres. And so we have plotted the genres on y-axis here, and we have plotted the budget on the x-axis here. And everything else remains the same as gghistostats. You again have the statistics, frequentist statistics in the subtitle, and you have Bayesian statistics in the caption. Now we go to hypotheses which relate to correlation. So you have two functions, ggscatterstats, which is about relationship between two numeric variables, and ggcorrmat, which is a relationship between multiple numeric variables, not just two. So again, in ggscatterstats, the arguments needed are data x and y. And here by default, you get raw data and distribution. You also get marginal distributions on the two axes. You get statistic and p-value. You get effect size and its confidence interval. And once again, you have Bayesian hypothesis testing and estimation. As for the rest of the functions, you can change the type argument to parametric, non-parametric, robust, or Bayesian. And the statistical details will adjust accordingly. You can also change the type of marginal distribution. You have 5 different options. You can plot histogram, which is what I'm doing here. Box plot, which is what I'm doing here. But other options are histogram, box plot, density plot, Weiland plot, and densigram, which is the default. This function is also helpful for conditional point tagging. So sometimes you want to tag specific points. So for example, here I'm interested in movies which have budget of over $150 million and IMDb rating of over 7.5. And we see that movie is Spider-Man 2. And this can be helpful to, for example, in an exploratory phase to check out which participant is doing some weird thing, in case you want to exclude that participant. The next function is ggcorrmat, which is a relationship between multiple numeric variables. Here, again, the defaults return effect size plus significance. So the correlation estimate and if it's not significant, it will be crossed out, and the caption will make it clear what the cross represents, which is that this correlation is non-significant at this threshold, and the p-value adjustment used was home correction because you have multiple correlation tests being carried out. And this function is very careful in terms of how it handles NAs. So in case there are missing values present, the caption will tell you what was the minimum number of what was the minimum sample size for the correlation pair and what was the maximum one. So you would know if the minimum sample size is too low, there are some correlations which cannot be trusted because there are just not enough observations. And here the legend will also make clear which correlation test is being run. This function can also be used to get a data frame. So all you have to do is just specify output is equal to data frame, and it will return a data frame. You can also do partial correlations by just setting partial is equal to true. The next one is a hypothesis about composition of categorical variables. So here you have ggpiestats function, which is if you like pies, and ggbosstats otherwise. So if you just have one variable, so for example, here in ggpiestats, you require data and just X argument. And if the data is stable, which is what Titanic data frame is, you can just provide the counts argument to frequency here. And it will return descriptive statistics, which is the counts and percentages for each level of the variable. It will return statistic and p-value, appropriate effect size and CIs, Bayesian hypothesis testing. Estimation is not currently available, but maybe in future this will be supported. Now, if you have two variables, so now the hypothesis about association between these two variables, you will see a pie chart like this, faceted by genre here. So here the research question that we're interested in is what does the composition of MPA ratings look like depending on the genre? So comedy versus drama. And we can see that drama films are more likely to get R rating from MPA. Now here also the defaults return descriptive statistics. As you can see, we get percentages, so it's a well-labeled pie chart. We get statistic and p-value, we get effect sizes and CIs. It also runs goodness of fit tests. As you can see, these are the goodness of fit tests for each facet. And it also returns Bayesian hypothesis testing and estimation, which is in the caption. And the test will be decided by the design. If it's a paired, it's an unpaired design, it'll be Pearson chi-squared. If it's paired design, it'll be McNemar's chi-squared. Now, some people don't like pie charts. I don't hate them, so I use them. But if you don't like pie charts, the equivalent would be ggpiestats. This is exactly the same as ggpiestats, only it will return bar charts. And the details remain pretty much the same, but the only difference is you get stacked bar charts. And last but not the least, sometimes you have a hypothesis about regression coefficients. This is probably the most general way of framing our research hypothesis. And for this, we have ggcoefstats function. So in ggcoefstats, you basically create a regression model object. So here, for example, I'm running a stats LM model, and you assign that model to ggcoefstats function, to the X argument, and that's it. That's all you require. And the defaults will return estimates plus its CIs. Statistic and its p-value will be displayed as a label to each estimate. And in caption, you will also see that it will provide AIC and BIC values in case you want to run multiple models and compare them against each other. It supports huge number of models, pretty much, I think pretty much any model that you can think of, it's supported. And this is thanks to the easystats R package system that I'm part of. So if you haven't checked them out, I would highly recommend that you check them out. In addition to these primary functions, there is also a grouped function for each of these functions that makes it easy to run the same function for all levels of a single grouping variable. So for example, if we look at the ggpiestats, it has the equivalent grouped ggpiestats function. So again, it's data and x, and the only additional argument that you have to specify is grouping.par, which is here is am. And so now it will run the same analysis for two different levels of am and combine the plot and return it. So this makes it easy to run the same analysis for across different groups. Yeah, and it requires just one additional argument. So far we have seen what the default plots look like, what the defaults for statistical expressions look like. But what if I don't like these defaults? Is ggstatsplot or are the ggstatsplot plots customizable? So for example, a lot of people typically would like to change aesthetics of their plots. So they want to change themes and palettes. But that's not an excuse not to use ggstatsplot, because you can customize this using three different arguments. So one is ggtheme that can be used to specify the theme that you like. So for example, here I'm using the HRBR themes package, and this is a theme from this package. As you can see, I hope you see that this stylistically it's really pretty. And I can also specify what palette I require from which package. So here I'm using the Darjeeling 2 palette from Wes Anderson package. But remember that the default palette is colorblind friendly. So if you want to change the palettes, just make sure that like the palettes you choose are colorblind friendly as well. You can also further modify the plots, because ggstatsplot returns ggplot objects. So all the functions from ggplot2 will continue to work with the return plot. So for example, here I run the ggbetweenstats function, and then I add to it that the duplicate, I'm asking it to duplicate this y-axis, and as you can see, it works. So you can also further customize the return plots using ggplot2. Sometimes you don't want so much statistical details on your plot, so you can basically strip it down to its bare bones. So for example, if you don't want to plot the centrality measures, you can set centrality.plotting equal to false. You can turn off the statistical analysis completely by setting results.subtitle equal to false. You can turn off the Bayesian analysis with bf.message equal to false. And you can also set pairwise comparisons, turn off pairwise comparisons using this argument by setting it to false. And it will just give you the bare plot. Sometimes you also just, you don't want to use the plot that ggstatplot is giving you, but you want the statistical details. So in that case, what you can do is you can use ggstatplot function and specify that the output that you require is not plot, but the subtitle. And you can store that in an object, and then you can prepare your own custom plot. So for example, here I'm using this package called ggiraffe_extra, and this function is ggspine. And so I'm preparing the graphic using a completely different package. And then I just add label to it using this object that I have created, which contains the statistical expression. So as you can see, that also works. So you can create your own custom plots and then use ggstatsplot just to get the expressions and display them on your plot. So here I would like to summarize what are the benefits of using this package. So first is that it supports different statistical approaches. You can think of it as a unified way to access different statistical approaches, which are parametric, non-parametric, robust, and Bayesian. Currently, all of these are not given by any unified package. Depending on the statistical approach, you will have to use a different package. Which leads me to the next point, which is that this can be your unified portal to access all these different packages. So let's say we wanted to do everything that the ggstatsplot is doing for us, but not using the package. So what we'll have to do is we'll have to use a variety of packages. One will be just to carry out the tests, for example, stats package. Another will be to compute effect size and CIs, which will be effect size, for example. Another package for computing descriptives, schema. Another package for computing the multiple comparisons. one for hypothesis testing, another for Bayesian estimation, so on and so forth. You might have to use a different package for non-parametric statistics, for another for robust statistics, and so on and so forth. Now, but here's the headache. Some of these functions will accept data frames, some will require vectors, others will require matrix, depending on when they were built or like who designed them. Everyone has a different philosophy about how these functions should behave. So the expected data type will be different. Some will require long or tidy data frame, or others will require wide or Cartesian format data. Some packages might not work with missing values like base vector, for example. Other packages might return lists, some might return data frames, some might return arrays. Some packages don't even work with tables. So this will create a lot of headache, because depending on which function you're using from which package, you will have to modify your data frame accordingly. But if you use ggstatsplot, it requires always a data frame, and it always has to be in tidy format. It always works with NAs, and it consistently returns a plot. So you don't have to, for one thing, figure out which package to use for which purpose. It will do all of that work for you in the background. So it saves a lot of headache, which means that you won't be frustrated while exploring your data. It really makes it easy to toggle between different statistical approaches. So for example, if you work on a manuscript and you prepare all your analysis in parametric, taking parametric approach, but the reviewer asks that all parametric tests should be changed to non-parametric, all you're required to do is change type is equal to P to type is equal to NP, and everything will change accordingly. So it makes it super easy to toggle between different approaches. It tries to follow best practices in statistical reporting. You always get test value, parameter value, statistic value, significance, if it's a frequentist test, p-value. You get effect size and its confidence intervals, and you also get number of observations. This also helps you avoid reporting errors. So I'm not sure about other fields, but in psychology, for example, a recent analysis found that half of all published psychology papers that use null hypothesis testing contain at least one p-value that was inconsistent with its test statistic and degrees of freedom. And 1 in 8 papers contain a grossly inconsistent p-value that may have affected the statistical conclusion. And this happens because people run the analysis using some software and then copy paste their results from that software to the document that they're writing results in, which can be Microsoft Word or something. But in ggstatsplot, since the plot and the analysis are yoked together, the chances of making an error in reporting the statistics are minimized because they are tied together. Making sense of null results. So when the p-value in NHST, like null hypothesis testing, when the p-value is over 0.05, the null hypothesis can be rejected. But does it mean that it can be accepted? And NHST can't really make any claims on that front. And a recent analysis found that in 72% of cases, non-significant results were misinterpreted, in that the authors inferred that the effect was absent. A Bayesian reanalysis revealed that fewer than 5% of the non-significant findings provided strong evidence in favor of the null hypothesis over the alternative hypothesis. And this is why the defaults in ggstatsplot are to juxtapose frequentist and Bayesian statistics on the same plot, because it helps you interpret the null results. So if the frequentist statistics is showing you that the p-value is over 0.05, you can look at the base factor and decide whether you should instead accept the null hypothesis over the alternative hypothesis. A few additional benefits of using the package. It requires minimal amount of code. Typically, if you're happy with the defaults, you require just data X and Y, which minimizes chances of error and makes for tidy scripts. It truly makes your figures worth 1,000 words, as I'm sure you must have noticed. No need to copy paste results to the text editor, MS Word, for example. Disembodied figures stand on their own and are easy to evaluate for the reader. There's more breathing room for theoretical discussion and other text. If you don't have to specify which tests were run, what were the results, etc., in the text, because that is reported in the plot itself, you have much more space left to discuss other more theoretically important things. And this is especially important if you're using these plots in journal articles, which have strict word count limits. And you no longer need to worry about updating figures and statistical details separately, because once you update the figure, the statistics will adjust as well. So I also want to take this opportunity to clarify some misconceptions, and I also want to talk about some limitations of this approach. So some of the misconceptions are: this package is an alternative to learning ggplot2. This is highly inaccurate. I've never made this claim. In fact, the more you know ggplot2, the better you'll be able to use this package, because then you can modify the defaults to your liking. Another is that this package is meant to be used in talks and presentations. You can use them, but I highly doubt if that's the best thing to do, because the default plots can be a bit complicated for effectively communicating your results in time-constrained presentation settings. For example, conference talks, where you may not have enough time to walk the audience through every component of the plot. It's meant for mass communication. Not at all. This will be way too complicated for the public. It's the only game in town? Not really. If you don't like scripting, you can also use this GUI open source software called JASP and JAMOV, which pretty much support everything that is supported in this package. And they're also designed in R. They use R in the background. What are the limitations of this package? So there are limited kinds of plots available. Yeah, this is something that can be worked on, but currently there are only very few plots available. There are very limited number of statistical tests available. This will always be the case. Like, it's no single package can handle all kinds of statistics. So for example, there's no time series analysis support. There's no multivariate statistics support. And in future, I might add support for these things, but there's always going to be this limitation that it doesn't, support all stats. It expects a non-trivial level of statistical proficiency. So this might not be very friendly for beginners who are suddenly confronted with a lot of different statistical details that they might not know what to do with. But the plots can still be helpful without the statistics. And a big limitation of this approach is that faceting is not implemented. So in ggplot2, you can do facet wrap, and it will replicate the same data structure for, the plot for different, across different facets. But this is currently not implemented. And this is because there is no, these functions are not based on JOMs. And writing a JOM will require a lot of effort, and I just haven't gotten around to implementing JOMs. Overcoming these limitations, I'll appreciate any contributions, big or small, that really helps to overcome, some of these drawbacks. Ways in which you can contribute: you can read and correct any inconsistencies that you find in documentation. There is huge amount of documentation on the dedicated website, and it's always helpful for someone to go through it and point out to me, like, if there is any mistake. Raise issues about bugs or features that you want. Review code if you have time. Add new functionality, which of course requires way more commitment. And if you either mention or cite you can mention or cite the software if you actually use in a publication, which gives it some visibility. You can also start it on GitHub. That also gives some visibility to the package. And lastly, I would like to acknowledge other developers, Daniel, Dominic, and Matten, who have helped me tremendously in supporting some of these features in their respective packages. I would also like to thank my advisors, Mina Chikara, Fahir Kushman, Iyad Rehban, who have financially supported me when I was I've worked with them as a postdoc. This is not my day job. And they were not, they never complained that I spent my time working on developing open source tools. And lastly, I would also like to thank two contributors to ggstatsplot who have either made any pull requests or like pointed out any bugs or requested any features. And you can find me on Twitter, on GitHub. You can send me an email on Gmail. Yeah. And if you want to see more information about this package, there's a dedicated website that you can visit. Yeah, that's all I have to share with you. Thank you.
So thank you for the talk. Sorry, I was just jumping in there, Bethan.
That's fine.
I just want to let you know that we're going to go through the questions that has been asked in the chat now. If you are a developer of a package or if you want to give a talk, as we talked about earlier, feel free to hang around after the Q&A and have a chat with us about the potential talk. And in the meantime, Bethan, if you want to run the questions.
Yeah, sure. Shall we take it from the top?
Yeah, I think that's probably best. I think the top question I found was, in the graphics with outliers, two descriptions have overlapped. Can I prevent this overlapping?
Yeah, I mean, it'll depend on the dimension in which you save the plot. And if you choose appropriate height and width, when you specify a ggsave function, it will adjust accordingly. You can avoid that overlapping. It uses ggrepel in the background, so you can also like modify arguments to that function and it will adjust accordingly.
Yeah, that was the follow-up question. Someone had suggested that it was ggrepel and had asked whether that was the case.
Yeah.
Excellent. So which Bayesian model underlies the Bayesian hypothesis test and the Bayesian estimates? Can we change priors? And I'm not a Bayesian, so I'm just reading this and Raul's laughing.
Yeah, I'm not going to be able to go through all the models that are used. Like it'll depend on the test, but on the website for the package, like for each function, I have written details for this, like what's the hypothesis test, like what's the model behind it and what the estimates, and you can change the priors as well. But yeah, you can just check out the website. Depending on the function, whether it's an ANOVA, t-test, correlation, like it'll be different. But like everything is done by base factor package. So everything that you can do with base factor package, you'll be able to do here with this package.
Yeah, so by the way, if you've been asking questions, you do have the power to unmute yourself and ask follow-ups if you have them. So do feel free to do that.
Just be aware that you will be part of the YouTube upload then, so that we don't do any GDPR whoopsies.
We'll turn the video off and allow further questions and unmuting later if you feel like you don't want to be part of the video. So is it possible to selectively turn off all the statistical annotations as well as layers like the violin plot over the box plot, in the interest of making things less cluttered?
Yeah, you can. You can turn, I think I also showed in one of the slides, you can turn off different components of the stats. You can turn off plotting of the violin plot. Yeah, you can take the whole plot apart and like just retain whatever you like. So it's highly customizable. Yeah.
Is it possible to use a package with Shiny and Plotly?
I'm personally not sure about Shiny because I haven't really used it. With Plotly, yes, but with Shiny, I'm honestly not sure. So I don't know what to say. Maybe it's something that I can look at.
It works with ggplot. Shiny work with ggplot. I don't know if the same elements maybe.
Yeah, then it should work with Shiny. But
So it's fundamentally a ggplot output that's
Yeah.
generated.
yeah,
Yeah, then it should work.
yeah.
Mm.
Yeah, but someone wrote like they want to develop like a Shiny version for this. So maybe they can show us how to do that.
Yeah, if someone, Hema, what's your name? If you want to jump in about your Shiny idea, I'm actually curious as to how this works. Otherwise,
We can try to do that in a DM and see if we can get a
Yeah.
answer to that later.
Yeah.
Continue with
so
the
there's a
Yeah.
very
questions.
simple question: is the presentation going to be shared? We have mechanisms to do that, but that's the speaker's choice.
Oh, it's on my GitHub page. I can also just send a link that you can put in YouTube channel or whatever. Yeah,
Excellent.
yeah, it's public.
Yeah, so that should be up in a day or two on the YouTube channel, and we can also put it in the meetup event, I guess.
Okay, cool.
Maybe it's a beginner's question, but can you from the numbers see what, if you, for example, make an A/B test, the sampling size necessary compared to the population from your output, the necessary before you have a significant result? You can determine if your result is significant. Or is that a question for another day?
Yeah, I'm not sure if I understand the question. Like for A/B testing, you want to display the results from A/B testing with ggBetweenstats or something, or?
Yes, but also, I mean, you have to be sure that if you, for example, you have big data, you have a lot of, you have a huge population, you're not quite sure of the population, and then you say, okay, I want to do this A/B test with this number of people in each group, and then determine if the results are actually would be significant with the number of people you have chosen. If it can help you do that, if that's something you have to be able to do.
But will you be like simulating the data? Because then it can do it. But it can't do power analysis, for example. It can't, for example, if you tell it like this is the minimum effect size that you expect for this effect, like it won't be able to tell you how many people you require in each group.
Okay.
Yeah.
Okay.
But I think we'll continue with the questions that we got in the chat to take them in the right order. And then if there's more questions, feel free to write them in the chat, Jens, or we'll open for mics when we're done with the Q&A.
So does the ggscatterstats use the Pearson correlation as default? And can you change it?
Yeah, it uses Pearson's R as default, and you can change it. So depending on what type argument specifies, because the defaults are always parametric, it's going to be Pearson's R. But if you change it to non-parametric, it'll be Spearman. If you change it to robust, it'll be a Winsorized correlation. And if you change it to Bayesian, it'll be the Bayesian variant of Pearson correlation.
Yeah, so this person said they were working with rating, so one of those should work. Yep.
Okay.
Yeah.
And there was some question about LearnR. I'm honestly not sure if this can be integrated with LearnR Markdown. I haven't done it, but I don't see any reason why not. Yeah, I think you can prepare a LearnR tutorial, although I haven't prepared it.
And then can the significance level be adjusted?
No, it always assumes 0.05. No.
Yeah, and then someone mentioned something to do with Shiny, but if they want to jump in, feel free.
Yeah, the what type of correction? Yes, you can specify what type of correction you use for multiple testing. Yeah.
So does the command for testing regression coefficients also yield the f-test for testing the coefficient altogether?
Not really, no. It'll just show the effect for each term. That's it.
Right, so you don't do some sort of combined F1, F2 score, I guess. Is that
No.
what they're talking about? And I think this is, can you use size as a third variable? So I guess, can you adjust the sizes on the plots the same way you can in ggplot?
Currently, no, that's not supported. But yeah, this is something that I want to support. That's especially important for scatter plots, where if you have a size variable that can really show you how many observations are, in particular spot. Yeah, but yeah, so it might be supported in the future, but not right now.
I think the next couple of questions have already been answered because that relates to ggstatplot usable with Shiny and with Plotly. But there was a question, can it be integrated with Learner and R Markdown?
Yeah, it can be.
That's really good to hear. And is it easy to return just the metrics without the plot?
Yeah, like I specified, you can use it. You can use it to get just the plot. You can get it just to just the statistical details. You can customize it any how you like, any way you like.
Nice. There was a question about faceting. Will that be implemented in a later version?
Yeah, so the current plan is to push version 1.0. Like I've been working towards that for like 3 years now, and I hope next year, but at least by the end of this year, I can push 1.0. And then the plan is to write custom JOMs. And if you write a JOM, then you can do facet. Then I can add support for faceting, but it's a pretty time-consuming process. And so far, my focus has been on actually adding support for as much stats as I can do. And then my plan is to work more on the ggplot side and create custom jobs once the API is stable.
I think that's good to hear. I think the last question then was, can you specify what type of analysis will run? Meaning what type of correction, what type of correlation, etc.
Yeah, what type of correction? Yes, the type of test that will be carried out will always depend on the type argument. So whether it's parametric, non-parametric, robust, or Bayesian will decide which test is run. Currently, you cannot specify it further. So for example, just for non-parametric, but I want a different kind of test, that you currently can't do. You just have to rely on the defaults that I have chosen. And I guess that's one of the limitations.
Is there any plans to implement further flexibility with regards to what kind of tests you can use?
Yeah, but
not on the priority list for 1.0.
No, not for 1.0. No.
I think that's all the questions we have from the chat, Bethan, unless you spotted something that I didn't spot.
Yeah, someone asked for the YouTube channel, so I'm just putting that in the comments.
The video will be posted as soon as I get back into the office tomorrow, because it will buffer from Zoom when I leave now, and then it will be available on Oslo USAR's YouTube channel. And
so I was thinking if we want to stop the video and open to anyone who feels like asking questions voice-wise, maybe that's an idea.
Sounds like a good idea. And then for those people watching on YouTube, you should have been here in person.